Picture buying a plane ticket the same way you buy a bus ticket. You open an app, pick a departure point, pay less than $5, and 15 minutes later you are lifted straight up off the ground in a two-seat aircraft with no pilot, no yoke, and no one at the controls at all. Not a drone carrying a package, a person, you. And when you land, nobody in the cabin touched a single flight control the entire time. That is not a concept video from a tech conference. That already happened for real paying customers in 2 Chinese cities, and the aircraft that made it possible spent 3 years fighting through the most conservative, most safety-obsessed regulatory process on the planet before it was ever allowed to carry a stranger. This video is about how that happened, what it actually took to get a machine with no pilot certified to fly people, and why the company that pulled it off is now being treated by its own government the same way China once treated its battery makers and its electric car companies. By the end of this video, you will understand exactly what a flying taxi actually is right now, not the version in a promotional video. The real one, ticket price included. If you like videos about the technology quietly reshaping how the world moves, hit like and subscribe so you do not miss what is coming. Let us start with the bet almost nobody else was willing to make. For the last decade, the eVTOL industry, electric vertical takeoff and landing aircraft, has been one of the most heavily funded ideas in transportation that almost nobody outside the industry could actually buy a ticket for. Billions of dollars poured into companies promising flying taxis, slick renderings of aircraft gliding between rooftop landing pads, investor decks full of market-size projections, and for years, that is basically all any of it was, because there was one problem sitting underneath all of it that money alone could not solve. Nobody had ever certified an aircraft with no pilot on board to legally carry a paying passenger, anywhere on Earth. You have probably already seen this hype cycle play out once and forgotten about it. Uber ran an entire division called Uber Elevate for years, publishing detailed white papers about flying taxi networks blanketing major cities by the early 2020s, before quietly selling the whole division off in 2020 once it became clear commercial certification was nowhere near as close as the marketing suggested. Dozens of eVTOL startups have gone public through blank check mergers since. Several have already gone bankrupt or been quietly wound down, and most of the ones still standing are still years away from carrying a single paying passenger. The aircraft were never really the hard part. Multiple companies built machines that could genuinely fly years ago. The hard part, the part that killed or stalled almost every competitor in this race, was convincing an aviation regulator to certify a passenger aircraft with nobody on board qualified to fly it. Every major aviation regulator, the American FAA, the European EASA, all of them, built their entire rulebook around one assumption baked in for over a century. There is a human being at the controls who can take over if something goes wrong. Strip that assumption out entirely, and you are not tweaking an existing rulebook. You are writing an entirely new one, from a blank page, for a category of aircraft that had never existed before, while somehow proving to a room full of the most risk-averse engineers in any industry that a machine making its own decisions is just as safe as a trained human pilot. Most companies in this race quietly built their aircraft around keeping a pilot on board specifically to avoid this exact fight, because it looked unwinnable in any reasonable time frame. One company decided to have that fight anyway. A Guangzhou-based manufacturer called EHang and its aircraft, the EH216-S, would spend the better part of 3 years and, by the certification team's own account, more than 1,000 consecutive days working alongside regulators to answer a question nobody had ever been forced to answer with this much rigor before. Can a machine be trusted to fly itself well enough that a government will put its name on the license? Before you can understand how strange the certification process was, you need to understand how strange the aircraft itself is. The EH216-S looks nothing like a helicopter and nothing like a plane. It is a wingless, 2-seat multicopter, 8 foldable arms extending outward from a central enclosed cabin, each arm carrying its own independent motor and propeller, 16 of them in total. There is no single point of failure holding the whole aircraft up. Lose one motor, even 2, and the remaining rotors redistribute the load and keep flying. It has a maximum speed of around 130 kilometers per hour, a range of roughly 30 to 35 kilometers on a single charge, and a flight time of about 20 minutes, which tells you immediately what kind of trip this was built for. Not a cross-country commute, A short hop, sightseeing route, or point-to-point connection across a city, the same category of trip a helicopter tour currently fills, just electric, quieter, and without anyone at the controls. Inside the cabin, there is no yoke, no pedals, no cockpit at all in the traditional sense. Just 2 seats, a pair of tablets showing flight data, and a network connection back to a ground-based command and control center that can monitor and, if genuinely necessary, intervene in the flight. EHang's own description of the design boils down to 3 ideas: full mechanical redundancy, so no single part failing brings the aircraft down, a fully autonomous flight computer instead of a human pilot, and a centralized command center watching every aircraft in the fleet at once, the way an air traffic controller watches a sky full of planes rather than one pilot flying one plane. That third piece is the part regulators had never had to evaluate before, because it does not ask, is this person qualified to fly? It asks, is this entire system, software included, qualified to fly? Which turns out to be a very different and much harder question. Think about what a normal pilot actually does during a flight. They are not just steering. They are constantly cross-checking instruments against each other, noticing when a reading looks slightly off, deciding whether that is a sensor glitch or a real problem, and making a judgment call about what to do next. Replacing that with software means the flight computer has to run multiple independent checks against every single sensor reading in real time, essentially voting on whether the data can be trusted, and it has to make that judgment call itself, every second of every flight, with no one to radio for a second opinion except a ground controller watching a screen from potentially miles away. If the fail-safe system detects something it cannot resolve, its only options are to keep flying the planned route or execute an automatic emergency landing. There is no version where it pulls over and asks a human what to do. Every one of those decisions had to be tested, documented, and independently verified before a regulator would sign off on it, which is a large part of why the process took as long as it did. Getting a new aircraft into commercial service is never just one approval. It is a ladder, and EHang had to climb every single rung of it from a standing start. At the same time, the regulator was still writing the rules for the rungs themselves. The first rung is the type certificate, which confirms the aircraft's actual design is safe to build and fly. China's Civil Aviation Administration, the CAAC, formally accepted EHang's application for this back in January 2021. Because nothing like the EH216-S had ever been certified before, the CAAC could not simply pull an existing rulebook off the shelf. In February 2022, it published an entirely new document called the Special Conditions for the EH216-S, essentially a custom-built certification standard written specifically for a pilotless, passenger-carrying multicopter, blending a century of conventional aviation safety principles with rules for a machine that had no precedent. On October 13, 2023, after more than 1,000 days of testing, data review, and back and forth with CAAC's own engineering teams, the type certificate was issued. It was the first one ever granted, anywhere in the world, for an uncrewed passenger-carrying aircraft. That was rung 1. 2 months later, in December 2023, EHang secured the standard airworthiness certificate, confirming that the specific aircraft rolling off the production line actually matched the design that had just been approved, and the first certified unit was delivered to a customer in Guangzhou days later. In April 2024, the production certificate followed, the approval that allows an aircraft to be manufactured at scale under a controlled, audited process instead of being hand-built one unit at a time, again a world first for the category. And in March 2025, the final rung, air operator certificates were granted to 2 separate operating companies, EHang's own Guangdong subsidiary in Guangzhou and a joint venture called Heyi Aviation in Hefei. The approval that actually allows a company to sell tickets and fly the public. Type certificate, airworthiness certificate, production certificate, operator certificate. 4 separate approvals, each one a world first in its category, each one built on a regulatory framework that did not exist when the process began. Here is the detail that separates this from every other flying taxi headline you have ever seen. Getting the paperwork is not the same as flying real passengers, and EHang knew it. Even after securing full operator certification in March 2025, the company spent almost a full additional year running internal trial operations before selling a single ticket to the public, quietly refining maintenance schedules, ground crew training, and fleet management procedures while the kayak monitored the safety record in real time. Only in March 2026 did ticketed commercial flights actually begin, at EHang's own headquarters site in Guangzhou and at Luogang Park in Hefei, with an early bird ticket price of 299 yuan per person, somewhere around $40 for a short sightseeing flight in an aircraft with an empty pilot's seat. EHang itself described the launch as the world's first commercial service of a pilotless, human-carrying eVTOL aircraft, and for once that specific claim is difficult to argue with, because there is currently no other country on Earth where you can legally buy that ticket at all. The business behind it is starting to show up in the numbers too. EHang posted its first ever GAAP quarterly profit in the final quarter of 2025, on record revenue driven largely by aircraft sales, including a single order for 50 EH216-S units from Guizhou Tourism Group. Management is guiding for roughly 600 million yuan in total revenue for 2026, an increase of about 18% year-over-year, and the company finished 2025 holding more than 1 billion yuan in cash. Its Yunfu production facility completed a second expansion phase, pushing total manufacturing capacity to 1,000 aircraft a year. And behind the two-seat sightseeing aircraft already flying, a longer-range successor called the VT-35 has already completed public demonstration flights and entered China's certification pipeline, aimed less at short scenic hops and more at genuine point-to-point regional travel. The aircraft is also being pushed well past sightseeing loops to prove it can handle more than a calm afternoon over a park. In December 2025, an EH216-S completed a 22-kilometer flight across the Qiongjou Strait, the open stretch of water separating mainland Guangdong Province from Hainan Island, a crossing normally made by ferry. It is a small distance by commercial aviation standards, but for a two-seat autonomous aircraft with no pilot and a battery, flying entirely over open water with no emergency landing site in sight for most of the route, it was a genuine stress test of the same fail-safe systems regulators had spent 3 years scrutinizing. EHang has also built a firefighting variant of the aircraft, the EH216-F, now stationed at a dedicated low-altitude emergency rescue base outside Beijing, which tells you the company itself does not see the sightseeing ticket as the ceiling of what this platform is for. None of this happened in a vacuum, and understanding why requires zooming out from EHang entirely. In 2021, the term low-altitude economy appeared for the first time in a Chinese national transport planning document, a fairly obscure bureaucratic phrase describing everything from delivery drones to air taxis operating below 3,000 meters. By 2024, it had become a headline national priority. By 2025, the Civil Aviation Administration of China was putting a number on it, projecting the low-altitude economy would be worth 1.5 trillion yuan that year alone, more than $200 billion on its way to 3.5 trillion yuan by 2035. It now has its own dedicated chapter in China's civil aviation law and its own department inside the country's top economic planning body, sitting alongside 5 other industries the government has explicitly designated as pillars of future growth. That kind of top-down commitment shows up in very concrete ways on the ground. Local governments are opening up airspace that used to require case-by-case approval, with Shenzhen alone now permitting flight across roughly 3/4 of its airspace below 120 meters without special clearance. At least 6 Chinese cities are currently running active eVTOL trials. Registered drones and low-altitude aircraft in China nearly tripled between 2023 and the end of 2025, and by early 2025, there were already more than 57,000 registered enterprises operating somewhere in the low-altitude economy supply chain, from aircraft manufacturers down to component suppliers and route operators. Provincial governments are handing out subsidies worth millions of yuan to companies that manufacture eVTOLs domestically or open new commercial routes, with some regions offering a flat cash reward for every new domestic air route a company opens and an additional bonus specifically for cross-border routes. And EHang is no longer alone. A second Chinese manufacturer, Shanghai-based Autoflight, secured its own COC certification in 2025 for a cargo-carrying eVTOL called Carryall, the first aircraft over 1 metric ton ever certified in the category, capable of carrying 2 tons of freight 250 kilometers on its own, and it has already flown resupply routes to an offshore oil platform that used to take 10 hours by boat. Autoflight is now pushing its 5-seat passenger aircraft, the Prosperity, through the same certification pipeline EHang just finished. Competition, not just policy, is now pulling the entire Chinese eVTOL industry forward at the same time. The parallel almost writes itself. This is the exact playbook China has already run twice before, with batteries and with electric cars. Identify a technology the rest of the world has not commercialized yet, have the state clear the regulatory path faster than anyone else is willing to move, let a domestic champion prove the model works, and then let competition and manufacturing scale do the rest. CATL did it with batteries. BYD did it with EVs. EHang, backed by an entire new pillar industry built around it, is being positioned to do the same thing in the sky. It would be dishonest to end this story sounding like flying taxis have already arrived, so let us be precise about what has actually been proven and what has not. Every commercial flight running today is a short sightseeing hop, not a commute. A 30 to 35 kilometer range and a roughly 20-minute flight time means these aircraft are not replacing anyone's daily drive to work yet. They are replacing a helicopter tour, which is a genuinely useful and profitable business, but it is not the point-to-point urban mobility network the entire industry has been promising investors for a decade. That bigger vision needs longer-range aircraft like the VT-35, an entire new layer of infrastructure in the form of vertiports and air traffic management for a sky full of autonomous aircraft, and years more of exactly the kind of safety data EHang has only just started collecting at real commercial scale. A handful of ticketed months in 2 cities is a genuine milestone. It is not yet a track record. It is also worth being honest about why Western regulators have not simply copied this model. The FAA and EASA have both taken a far more conservative position, requiring a pilot on board every certified eVTOL currently working toward approval in the United States and Europe, specifically because neither regulator is yet willing to certify full autonomy for passenger flight the way China's CAC did. American competitors Joby Aviation and Archer are both deep into their own certification processes, with Joby roughly 85% through FAA-type certification, and Archer having secured full acceptance of its compliance methods, and the FAA selected 8 demonstration projects in early 2026, aiming to get early commercial flights in the air by summer. But every one of those aircraft will have a human pilot in the seat when it happens. China chose to solve the harder problem first. Whether that turns out to be the right call over the long run, in a Western liability and insurance environment built entirely around having someone to hold responsible in the cockpit, is a genuinely open question, and it is the single biggest reason this technology may take much longer to reach American and European skies than it took to reach Chinese ones. There is a quieter warning sign worth mentioning too. EHang's own aircraft deliveries actually slowed sharply in the first quarter of 2026, just 4 units sold compared to 11 in the same quarter a year earlier, even as the company was preparing to launch its first ticketed flights. Management's own explanation is that the business is shifting away from one-time aircraft sales and toward recurring ticket and platform revenue, which is a normal thing for a maturing operator to say, but it is also exactly the kind of number that deserves watching rather than taking on faith, especially for a company still transitioning from selling machines to selling flights. EHang is not staying inside China's borders while it waits for the answer to that question. The company has run validation flights with regulators in Thailand, Qatar, and Japan, including a demonstration flight near Mount Fuji in partnership with a Japanese real estate developer, and it completed its first human-carrying flights in Indonesia, all while working toward its first overseas commercial operating license, with Thailand currently the furthest along. None of those have converted into another country's version of the Guangzhou ticket booth yet. Getting a foreign regulator to accept a Chinese-built, Chinese-certified autonomous aircraft is its own political and technical negotiation, separate from anything CAC already approved, and it will likely take years rather than months in most of these markets. But each flight is effectively China exporting not just an aircraft, but the regulatory template that made the aircraft legal to fly in the first place, the same way it exported battery chemistry and EV manufacturing capacity once those industries had already matured at home. Zoom all the way out, and the shape of this story looks familiar. A technology that sat in investor pitch decks for a decade, blocked by a regulatory question nobody wanted to be first to answer. One government willing to write an entirely new rulebook from scratch to answer it. One company willing to spend 3 years and 1,000 days proving a machine could fly itself well enough to be trusted with a stranger's life. A second domestic competitor already pushing a cargo aircraft over a ton and a 5-seat passenger design through the same pipeline. And now, a $5 ticket, sold from an app, for a seat with nobody in it. Whatever happens to any single company involved, the actual bottleneck holding back flying taxis worldwide was never really the aircraft. Multiple companies in multiple countries had something that could fly years before EHang got its certificate. The bottleneck was always convincing a government to sign its name to full autonomy, and that signature has now been given, once, for the first time, in China. If this video showed you a piece of the transportation world you had not seen coming, hit like, subscribe, and turn on notifications so you catch the next one. And here is a question for the comments. Now that the hardest regulatory question in aviation has actually been answered once, do you think it will take the rest of the world years to catch up, or decades?